All right, so first thing, let's go quickly over the syllabus, and then I will show you where to access everything. I do not use Blackboard, so if you're one of those people that really like Blackboard, I'm sorry. I actually use my own website that's completely open, and you can just do whatever you want, like get all your information, everything else on it. It's really easy for me to use. So I kind of tend to use that just because it's simpler. And I don't put grades and stuff up there anyway, so it's not really that we need that stuff. All right, so hopefully everybody's here for elementary statistics, MAT123. If you didn't grab a syllabus, the syllabuses are right up here on the front of the table up there. I think I printed out 25. There's 28 people here, so if I run out, I'll get you one next time. You should have, can I borrow your book real quick? Or just hold it up. That's the book you need. Just need some access. You do not need the physical book. If you have online access, that's fine. You do not need any online access, like any online programs. WebAssign, My Math Lab, none of that. You do not need the access code for it at all. So if you happen to buy a book that has the access code in it, don't open it, because you can sell the book to somebody else for more when they need the access code. So definitely use that as an advantage for you. But yeah, everything I'm going to need or you're going to need will be posted. So, and all the tests and stuff will be done in class. So you won't need any kind of online access for that stuff. The grading is pretty simple. You got 4 tests, 15% each. So that's 60% of your grade. The final exam's 30%, and it is a cumulative final exam. So we will go over everything for that. And then I got my 10% is my fudge factor. That's just participation. As long as you come to class and don't annoy the total crap out of me, you get your 10%. So for all intents and purposes, I use that because I've had some people who don't show up to any classes except for the tests, and I don't think they should get 100 for that. So that's kind of my little fudge factor in that regard. So 99% of the people always get the 10%. So that's not that big of a deal there. The tests will all be in class. They'll be during the period, so you don't have to come before or after. The final exam will be able to be done in class as well. I will, because of the length of the class, because we only meet 1 day a week, we will do a little bit of a review before the test. So 6 o'clock, I'll probably do about a half-hour review before the test, and then you'll have from 6:30 to 8:45 to finish up the tests. So we will go over a little bit of the stuff before you actually have to take it. You are allowed a note card on the test. So a 4x6, 3x5 index card. So if you want to get some index cards, you can bring a note card to the test. I know people, why can't we use open book and stuff like that? Because you spend 90% of your time flipping through the book to find something and end up running out of time on the test. When you go through and fill out the index card, you're studying for the test because you're writing down stuff you need to know. So it's actually a study habit too, to really get into practice for it. And the amount of formulas and stuff that we're going to need, if there's a ton of formulas, I'll give you a formula sheet for the test, and I'll tell you that beforehand. So use the index card to write down little notes and stuff, definitions and things that you're going to forget, stuff like that. So every test you'll be allowed to use that. If you need me for any other reason outside of class, you are more than welcome to email me. I get back to my email pretty quick. I have it up on my computer all day. So if it comes in, as long as I'm not physically teaching a class, I teach high school in Hartford. So as long as I'm not physically teaching students in front of me, I can reply to emails pretty quick. And if you need to meet outside, like you want a one-on-one session or something like that, we can either do it online at a convenient time for both of us, or I'm also here on Tuesdays and Thursday nights for my calculus class. We can always meet after that class. I think other than that, the last on the back of the syllabus is basically the sections that we're going to be covering. You should work on the odd problems if you're going to practice them. All my questions from the test will come from the exercises in the book. So if you do all the questions in the book, you will literally have been able to have done every question that's on the test. So the odd ones, I believe in this book, should have the answers in the back of the book. So practice with those. Unfortunately for this book, I don't have the solution guide for the even answers. So practice on the odd questions. Any questions on the syllabus? All right. This is my website. The website is bakersmathclass.com. Really straightforward and simple. Works on any device, mobile, web, tablet, phone, anything you want. Since this is statistics, you would just click on statistics. and that's where your information is going to be. So right up there now is basically just the class list. So, but I can show you, like if you look at my college algebra class from last session, or for the fall of last year, you'll see you have the top cover stuff we're going to be covering, and then the video of the lesson that I taught that night. So that's basically what you guys will see. The sections that we covered, and then the video of that lesson will be posted up there. So you can easily access that elsewhere. All the videos are going to be hosted on YouTube. They're going to be unlisted, so not everybody's going to hear and see them. So if you ask questions, don't freak out. Nobody's going to be basically watching them except for you guys. So, but that also means the nice thing is that you can watch them everywhere. So it's like anywhere you can use YouTube, you can watch it. So you don't need anything special to be able to watch the videos for the class. Any questions or concerns with that? Okay. All right. I think that's basically all the overview. Anything that I didn't go over that you guys want to know? All right. Welcome to the first math class that you can learn how to lie in. I love statistics because it's the one class, it's the one form of math that we use all the time. And you can convince pretty much anybody of anything if you know how to deal with numbers. And you can look at one data set and come up with two completely different conclusions. So that's why I like to say statistics, the math you can lie with. Every other math, there's a specific answer and everything's right. Not so in statistics. So we're going to go over, if you have your book, this is literally lifted right from the book. So if you do have a book, you want to flip through it, I pulled this stuff right from the book. So I don't like their PowerPoints. And no, I'm not going to read you everything on the screen. So, but we are going to talk about it. So I think this is page, let me go back and remember that's on. Because I have a digital book, so it's a little different. First thing I talk about page 6. Actually, before we get into this, while you guys are flipping through your book to try to find the page, what do you guys know about statistics? What are some things you actually remember or have learned before or think you know about statistics?
I heard a class once. It was about like reading graphs and seeing trends.
Yep.
Kind of like writing down the patterns and data.
Yep. Very good. Anybody else? Yeah.
I took a 2-year math class in school that I went through pre-algebra and calculus. I was really bad at it. And I do remember the charts that we did.
Bell charts?
I think so. That's what it was.
Yeah. Anybody else? All right. Yeah, we're going to look at lots of graphs. Definitely looking at trends, figuring out what is going to happen. The bell curve is one of the big things we're going to talk about, normal distribution, things like that. So you might have seen in your high school career some basic statistics, mean, mode, and median. Huge. Average is basically mean. So anytime you do an average, you're basically doing statistics. We're just going to go into a little more complicated version of statistics at that point. Where are some places you've seen statistics?
During elections.
Elections, huge. Well, actually, I'll probably pull in some of that data and stuff. We'll get closer to it later in October, November. We'll talk about some of that.
Medical field and sports.
Yep. Medical field, there's a lot. Sports is huge. Okay. What sport has the most statistics? What sport? Yes, baseball is the most statistically applied sport. Just because, like most other sports, you still use stats, but most other sports don't have as many games that they play. So what happens is the more data you have, you start regressing to the mean, which is one of the things we're going to talk about. And in baseball, that's what happens. New York Yankees are a perfect example of that this year. They were on fire at the beginning of the season, like literally historic pace. After the All-Star game, they have tanked. It's called regression to the mean. They were doing something that was literally shouldn't have been done, and now they're doing something that also shouldn't have been done. Basically, but at the end of the season, they'll be about to where they were supposed to have been. So those are some of the things that happen over that long of the season. Where are some other places that you see stats? News, Facebook. Everybody and their mother uses statistics on Facebook and has no clue what they're talking about. Yes. Was it? Studies?
Like games, like video games, or like tabletop.
Yep. Lots of tabletop games use statistics. Monopoly, Yahtzee, all those things. Any kind of card game. Go to the casino, all stats. So probability and statistics. So who is it? I'm one of those people who like to argue on Facebook, and since I'm a mathematician, I know stats and everything else. It's like people literally end up getting totally confused and giving up. So today somebody posted something. It was like, so I teach at the Hartford schools, and like they wanted to be safe. Every kid should still be masked, and lunches should be outside. No kid should be inside without being masked. And I'm like, why? Well, because kids are dying of COVID. I'm like, okay. Do you want to take a guess how many children have died of COVID in the entire world? If you had a guess, 4.5 million people have died worldwide of COVID. How many of them were children under the age of 18? Huh? It was actually 17,000 total worldwide. In the United States, it was under 1,000. In 2020, 753 children died in a car accident. So since 2020, more children have died in a car accident in the United States than of COVID. So it's like, so when you start to look at statistics and numbers and everything else, people start throwing out all these percentages and numbers and stuff, and it's like you can start to get bogged down. It's like it's you have to look at the difference between the hysteria and the hype and everything else. And if you start when you start looking at the actual numbers, you can start seeing a lot different picture of what's going on, and you can actually start to realize that, well, in some situations, yes, it's horrible. Absolutely, 1,000 children dying is a horrible thing. But there's risks that we put up every day in life that are more than that. And we don't think twice of it because we just do it. We've accepted that as part of life. So those are some of the things that when you start looking at numbers and start looking at data, we can start having some of those conversations. And the more you understand, the more informed you can be about those conversations. And the more things that you can catch politicians just completely and utterly lying because they have no idea how to do math. Here, not a statistics problem, but a very funny math problem. So did anybody see the article about Avis rental car? So Avis rental car in South Africa charged a person $6,000 for the rental car. They were told that they had done 23,000 miles in 3 days. They used their car for 3 days and did 23,000 miles in that car. Came out to be that person had to do 345 miles an hour, nonstop for 3 days to hit that. And somebody actually put it in the computer and thought it was correct. So when we start looking at numbers, that's the point of math. It's like somebody should have looked at it and go, this doesn't seem right, but nobody did. All right, let's get into the book and start looking at some actual statistics. First thing we're going to talk about is descriptive statistics. These are the ones that you're most likely to use and most likely to see. Descriptive statistics are when you're organizing and summarizing information. So mean, mode, median, descriptive statistics. This is one of those examples, 1948 baseball season. They played the Washington Senators, which are now the Nationals, because that team actually went to Montreal and then back. Played 153 games, winning 56 and losing 97. So that's a descriptive statistic. So if you look at that and get that winning percentage, that's a descriptive statistic. All right, it's just describing information. Very simplistic. Batting average, another descriptive statistic. Descriptive statistics work really well, except they don't really expand well. So Bud Stewart, whose batting average was 279, was that season. Great. The next season, he could hit 350. All right? Or he could hit 100. It's like, so when you look at a descriptive statistic, it works just for that data, especially if you only have a little bit of that. You can't really extrapolate that further on. So I got to remember to switch the other one so I don't talk when you don't see something. Where is it? Slide. That slide. There we go. Next thing, which is probably one of the more important aspects of statistics. is population versus sample. If I wanted to do a study and I wanted to find out how many people like Hershey candy bars in the entire United States, how many people do you think I should ask? So if I wanted to find out how many people in the United States like Hershey candy bars, how many people should I ask? So remember, there's about 350 million people that live in the United States. Should I ask them all? No. It'd be almost impossible, right, to ask them all. So if I was going to ask them all, that would be a population study. Okay, I'm asking every single person in the population. Obviously, not able to be done. All right, if I wanted to find out here how many people like Hershey candy bars, I could ask all of them, right? And that would be a population study, but it would only account for this one class. Okay, I could not take the data from this class and go next door and say, oh, 54% of you guys like Hershey candy bars, because there's no connection to it. All right. If I took a sample of people, so if I only talk to, say, 1,000 people, would that give me enough data to determine how many people in the United States like Hershey candy bars? So how many people do you think we should talk to figure out how many people in the entire United States? Yeah.
I don't know if like the question is how many people. I would think it would have to do like you'd have to ask like multiple demographics.
Yes. Oh yeah, we're gonna talk about that a little bit, like figuring out like the different groups and stuff. But even if I split up and did all that stuff, how many people do you think we should ask? How many phone calls do you think I should have to get?
10,000.
Crazy question is, it actually is 1,000. We're gonna figure that out why later on in the class. We're gonna figure out exactly how many people you have to ask to get the data that you want. And actually for the entire United States, if it's done correctly, by randomization and looking at demographics and stuff like that, you only have to ask about 1,000 people in the United States, any question you want, to get data that would show the demographics for the entire United States. So all those polls and stuff that you see on Facebook and everywhere else, and on the news saying 47% of the people agree with this, or 75% of the people agree with this, they asked about 1,000 people. Okay. And one of the things I used to tell my classes all the time was, if I'm going to start calling somebody, because a lot of polls are done by call. How many of you answer a phone call for a pollster? And if they tell you they're a pollster and they want to ask you questions, how many of you instantly hang up on them and don't answer their questions? Right, pretty much everybody, right? What's the demographic of people that would answer that phone call and answer all the questions? Exactly. Your bitter old females that were sitting literally by themselves and have nothing else to do but talk to somebody on the phone. Okay? That's how things get skewed. And that's where that demographics comes in to start looking at stuff. Problem is when they have a certain amount of time to do things, some of that gets thrown up by the wayside. And it's like, we called 10,000 people and only 700 answered the phone. We got to take the data we get. And that starts skewing things. And we saw that in 2016 when a lot of the polls came back and said Hillary Clinton was going to win. And they had polls up until literally the day of the election, actually after the election, that still said Hillary Clinton was going to win. But Trump won. Because the data that they were getting was skewed, was inaccurate. And what they found out actually afterwards they were looking at is, a lot of people would tell somebody on the phone that they were going to vote for Trump, yet they went and voted for Trump. So they actually lied to the pollsters on the phone and said they were voting for Hillary because that's what they thought they wanted to hear. So they changed a lot of the ways that they do the polling since then to become more accurate. So, but that's where the difference between a population and a sample. Samples are, we take small groups, and we're going to talk a little bit about how to find some of those small groups and different ways to look at it even in today. And then when we start looking at studies, we're going to actually start doing some of that stuff as well. All right. There's a couple different types of statistics. So we talked about descriptive. The next one is inferential. Who wants to take a guess what that word means? Without reading the actual definition. Inferential.
For data.
Yeah, you're inferring something. So this is where you're looking at a sample, and then you're going to project it onto a population. You're going to infer that the general population means the same as the sample does. So we just talked about Clinton and Trump. There was actually a one well before that point too that had happened. It was President Truman versus Thomas E. Dewey. And if you go back in history, and even in your history class, they might have, in your history teacher might have shown you the newspaper that says Dewey wins. They ran newspapers saying that Thomas Dewey won the presidency over Truman because that's what their data showed. But Truman won the election when they actually did the counting. So, and Gallup and everybody else changed their methods after that one too, because they found out that there was other things going on that showed it. And actually, they said that Truman was only going to win about 45% of the vote, 44.5%. He won over 49% of the vote, which is also why at the bottom of every poll you see on TV or anywhere, what does it say? There's something on the bottom of every single poll in the fine print that nobody ever looks at. It says plus or minus 3%. So when you're doing all the stats, when you're doing all the calculations, you're never going to get an exact number. Okay? The more people you ask, the smaller that number gets. They have determined that plus or minus 3% is good, and that's about 1,000 people asking. Okay? The other thing you'll notice is when people are closer than that, you'll say that they're in a statistical tie. So if one person's at 44%, one person's at 46%, they're within that margin of error, they say it's a statistical tie. Okay, but if one person's at 44 and one person's at 48, the one at 48 is winning because it's outside of that, plus or minus 3%. So inferential statistics is when we take data and then we infer what's going to happen in the general population. Baseball is going to come up a ton of this stuff. I like baseball, but that's not why it's going to come up a ton of stuff. It's just there's tons of statistics for it. So we've had recent times. This book was written before the modern, like the past few years. So we were recently in what's known as a live ball era of baseball. So a lot more people are hitting home runs, balls going out more, and what they said was something was different with the ball. Okay, so they felt that the players and the pitchers thought that the ball actually was a livelier ball. It was springy. Right? And they've actually done studies on this since then. And they actually found that there was something different with the ball. So one company makes all the baseballs. I think it's Rawlings now. They make every single baseball. And they're supposed to make them into an exact specification. But as whatever you're making things can vary. So they actually found out that the ball is slightly different. Now, in the past year, they went back to the old ball. They changed something to get it so it's more of a dead ball. Same thing happened in the 1970s. So in 76, they had 616 home runs. Or sorry, 762 home runs in the first 600 games. The next year, they had over 1,000 home runs in the same amount of games. So like something's up. So they did a study. Did they cut open every single baseball? They did a what? They took a what? They took a sample. So they took a sample of them to do the study. And then they inferred what happened to all the baseballs. And they actually did find that it did actually change. So that was the year they actually changed companies, and the new ball was definitely a livelier ball. All right, we're going to... Actually, no, I can't put those on. All right, so when we're looking at the baseball thing, we took a sample of all the baseballs. What do you think that would be called? An observational study or a designed experiment? So That one would be an observational study. The difference between the two is slight. So yes, they did take the balls, cut them open, and looked at the sample, but they didn't design all the other stuff that went into it. Okay? So here's a couple examples. So the first one was they chose folic acid and birth defects. For several years, evidence has been mounting that folic acid reduces major birth defects. So what this doctors did was they enrolled 4,753 women in a study. And they did a blind study, double blind, where some of the women took folic acid, some of the women did not. And they collected that. Another study was dealing with vasectomies and prostate cancer. They looked at the relationship between vasectomies and prostate cancer, and they found 113 cases of prostate cancer among 22,000 men that had a vasectomy, and only 70 cases among 22,000 men that did not have a vasectomy. So one of those is an experiment, and one of those is an observational study. Which one's the experiment, and which one's the observational study? Right. So the vasectomies is an observational study. They looked at this data that was out there. They didn't control any of the other variables. So those 22,000 men that had the vasectomy might have also had other health conditions. They don't know. They were looking at two things: vasectomies, prostate cancer. Okay. The folic acid birth defects, that's an experiment. That was a designed experiment. They controlled as much as they could the things that were going on. Okay. So, which one of those two studies would you consider to be more accurate?
The design.
Yeah. Because when you can control the aspects, you then can figure out if that one specific thing was the causation. Okay. So your designed experiments are typically more accurate and more, they can help establish causation. So when they did that study, they found that folic acid did make a difference in birth defects. So they dropped it from 13 per thousand, from 23 per thousand cases. So, and they were able to do that with that study. That's actually the biggest. So when you're looking at observational data, you're picking the data you want to look at. Now, you can have thousands and thousands of cases, but you don't control things. That's one of the biggest things with the data that we've seen with COVID recently. A lot of their studies are observational studies because they don't have the ability to, as horrible as this would sound, if they want to do a true study with this, they would have to infect people with COVID and have people who were not infected with COVID and do the actual test on it, which nobody's going to allow anybody to do that. So they can't necessarily do a very designed experiment with this. So when they were looking at these studies, a lot of them were observational. And even the designed experiments had a lot of flaws in them because they couldn't control certain things. So one of the first studies that was done when they were looking at the vaccine, they said, well, this group of people got the vaccine and didn't get COVID. This group of people didn't get the vaccine, and this many more people got COVID than the other one. But they didn't look at, because they had to tell them what they were getting. And they didn't look at what the people were doing outside. At that point, universal masking was in place, social distancing was in place, schools were closed down. So the people who were getting the vaccine, who volunteered to do this, would have been the people who were following all those guidelines to begin with. So they were already at less risk of getting it to begin with. So that skewed some of the data in looking at it. So a true design experiment would try to have eliminated as many of those possibilities out as possible, so that people that didn't want the vaccine were still going to be in the study to figure out, does it actually make a difference? So, but when you're taking volunteers, you might not have that opportunity to be able to do some of that stuff. So the longer we look at the data, the more accurate that information becomes, because we have In this case, the observational studies, we have a lot more data, and we can start to make some of those determinations. All right, so the next thing we're going to look at. How do we figure out who to pick? So you brought up, we got to look at demographics, right? We can't just randomly pick 1,000 people in the United States and say, we're good. Like I can't take, okay, I'm going to take every single student that's in this building right now, ask them a question and say, when I get it, I can say this is the entire United States does this. That's not random. You're a very specific demographic. As much as everybody thinks, oh, there's lots of different demographics in here, you guys will still fit a very specific demographic. So we need to have a way to be able to choose our information. So what are some ways that you think I can choose a sample? If I wanted to find out how many people I heard came from, how to choose a good random sample? Yes, I'm going to tell you a bunch of ways. I want to see what you guys come up with first. What would be a good way to take a random sample?
People that like chocolate, different types of chocolate, people that don't like chocolate.
Okay, but that would mean you'd have to ask more questions ahead of time. If you just put a poll on your Facebook page, would that get you a random sample? Huh? There's people you know. I would hope there's people you know. Some people have thousands of people on Facebook. I'm pretty sure you don't know them all. But would that be a good scientific poll? Why? If CNN put a poll up on the front of their webpage, would that be a good scientific poll?
No, because it's mostly like 50-year-old Democrats.
Okay.
You know? Like it's one demographic.
You just look at a piece of demographic there. What if I hired all the major news organizations to put the same poll up on their page?
It would only be people who watch the news. Like I don't watch the news.
Okay. What if I put a poll up on TikTok?
Like a lot of young people.
Get a very specific demographic, right? I get a younger demographic than if I put it on CNN or Fox News, but it would definitely be still a specific demographic. Problem with all those polls, it actually has less to do with the demographic and more to do with it's voluntary who's going to take it. You have no control who is taking it. You don't know anything about them after they click the button. Okay? And as the Hartford Yard Goats found out, asking the internet sometimes gets you horrible information. That's literally how the Yard Goats became a team. They asked the internet, what would be a good name? And Yard Goats won. I'm asking why. For my entire life, we did not have a bunch of trains, and we don't definitely have Yard Goats. But they're now our baseball team. So you get a skewed set of information. It's not a good sample. It's not randomized in any way. Okay? So if I gave you if I gave you a telephone book, which probably half of you have never seen, if I gave you a telephone book and I told you to randomly pick me 100 people, how would you do it?
Well, people like
You would. Would you just go to the first page and pick the first 100 names? Okay, flip a page, pick a person, flip a page, pick a person. Is that random? Yep. And that would be actually completely random. That would actually be a good way to randomize. Nowadays, we have computers. Okay. Well, they'll dump everybody's phone number into a computer, and the computer will just randomly spit out numbers. And half the phone numbers they spit out probably aren't even an actual phone number because it's literally just random numbers. So they don't even need the phone numbers in it. It's just literally a random number as they call. And the computer dials it, and if it connects, it sends it to a person. That's all they're doing. All right? That's a simple random sample. You're going to get a bunch of people, and as we've already determined, you're going to get a bunch of old people probably answering the phone that wants to talk to you. I apologize to all the old people. I am old, I agree. One of the things that I hope after this class is over is if a pollster or somebody else calls you up and asks you questions, answer them. It's honestly, it's the best way to get your information out there. Most things, most studies, most research, most proposals, everything else, they need that data to decide what they're going to do. All right. So they hire pollsters to get them that data. So the best way to get things changed is literally to answer the phone or to answer that email and answer their questions. And there's lots of groups that actually pay good money to do that. Harvard Research Group actually pays people to go do focus groups and stuff like that. I get paid $150 to sit in a room for an hour talking about my internet. It was great. Yeah.
Okay, so the best way to have a random sample is to have the computer randomly.
No. So it is one way. We're gonna look.
But then that would be mostly older.
Yeah, you have it. When you just randomly call somebody, they're gonna ask you. You're gonna ask a bunch of demographic questions to hopefully fit you into certain categories. But you're still basically stuck with whoever answers the phone. Another one that they do a lot of times is they'll have people that will randomly walk around with clipboards and are supposed to just ask people questions. So I went to the Dragon Boat Festival in Hartford last weekend. Yeah, last weekend. Or no, not this past weekend, the week before. And there was a person walking around with a clipboard asking questions like, were you happy? Did you enjoy yourself? What could we have done better? Those things. Because they weren't going up and asking every single person, it was still a random sample. It has a little drawback because you're going to get people either that loved it answer the questions or absolutely hated it and just wanted to trash you answer the questions. You typically don't get people that are ambivalent, going to take the time out to answer your questions. So those are random samples. Now, not the best way to do it. It is a way to do it. We're going to look at a few other ones too. I guess I'm getting tired. It's first day of high school today too, so it's been a long day. All right, so actually there's a we won't do that one. So two of the ones I talked about is simple random sampling, a sample procedure where each possible is equally likely to be occurred. And then simple random sample is just that group you get from it. All right, a couple ways that they use to do those is random number tables and random number generators. We talked about how computers do those. So it could be your address, if they're going to be mailing things to you to get asked for information. It could be based on social security number. It could be a ton of things. We give more data away every single day than you'd imagine. All right, this is why Facebook, Google, and all those things are free, because they make more money off your data than they would ever get by asking you for money. So that's why the joke was like 5-10 years ago, it's like, would you pay for Facebook? I'm like, absolutely. I'd pay for Facebook in a heartbeat if they stopped selling my data. So it's like, you get one or the other. You don't want to pay for it, they use your information. And you have to be okay with it because you agreed to it when you click that button. All right, so another option is known as systematic random sampling. So Professor Hassett wants to sample 15 of his 728 students who are enrolled in college. So they have 728 students enrolled, and they only want to ask questions to 15 of them. Okay, so the question is how do they pick those 15? So he's going to use what is a systematic random sampling. He's going to divide the population size by the sample size and round down to the nearest whole number. So we want 15. So he's going to take the 728 students and divide it by 15. So if we take, somebody's got a calculator real quick. What's 728 divided by 15? Okay, so we got 48.5. So that means we have 48. So we're going to have 48 different groups. Because we're going to round down. So now we're going to use a random number table or a device or random number sample to pick a number from 1 to 48. Okay, so somebody pick a random number from 1 to 48. 36. I heard 36 first. So we're going to pick 36. So now he's going to go through and ask every 36th student. So all the students will be listed. Every time he gets to 36, he's going to ask that person a question. That's known as systematic random sampling. Okay? In this situation, we don't necessarily have to worry about demographics because he's only looking at students who are enrolled in college algebra. Okay? So if he takes all 728 students, organizes them by ID number so they don't know who they are, or names or anything else like that, and just then went down and picked every 36th person, he'd get 15 out of them. And then he can ask those questions. So that's another way to do random sampling. Okay. Again, some of these ways are better for certain situations than others. So in the example that they did, this is what they had. They chose 22. So it was the 22nd person in every group. So it was 22 and then added 48, got 70, added 48, got 118. So those were the ID numbers that he was going to select out of it. Okay. So just another way to ask those questions. Oh yeah, I said a few times, I teach high school. If you have questions, just bug me. You don't have to raise your hand and go, excuse me. Nope, just literally yell it out. I'm used to it. If I say something you don't understand or you want me to explain something again, just ask it. All right. I do not mind any of that. I feel like I'm going really fast and I might be, I don't know. All right. Here's another way that we can look at it. I'll make this a little bigger. So another one is called cluster sampling. So cluster sampling is when we divide populations into groups or clusters. And then we obtain a simple random sample of the clusters. And we're going to use all members of the clusters. So in this one, the key piece to this one, so let's say we had 300 members of the population that are divided into clusters equal size of 20. So how many clusters do we have? I have 300 people, each one has 20 people in it. You're like, wow, I thought this was a statistics class. I have to do algebra now. It's 300 divided by 20. Cell phone calculators are amazing. Oh. 300 divided by 20 is not 60. It's 15. Very good. All right, so we have 15 groups. I wanted to speak to 60 people. So how many of those groups do I have to pick? Each group has 20, and I want to speak to 60. I need how many groups? 3 groups. So out of those 15, I'm going to pick 3. Those 15 groups have to be randomized. Okay, they can't be random. They can't be alphabetical. They have to be completely randomized. And then I'm just going to pick 3 of those groups. And that's going to give me a random sample of the entire population. Okay, because the clusters were randomized, by picking 3 of them to get my 60, that 60 is randomized. That's known as cluster sampling. So here's a great situation of cluster sampling that was actually used. So There was a city in Arizona that wanted to create bike paths. Bike paths are great. Keep people safe as long as they're driving bikes. So to save time, the planner decided to use a cluster sampling. The residential portion of the city was divided into 947 blocks. So they basically took each block of the town. Each block contained about 20 homes. They wanted to use the cluster sampling to contain a sample of 300 homes. So how many blocks do I have to go and ask questions? Each block had how many houses? 20. And I want 300 homes. So I need how many blocks? 15. Okay. So I'm going to hire 15 people to go out and walk to each of those 15 blocks and ask the questions to these people. All right. You think we're going to have a good study? You think this is a good use of cluster sampling? Was it simple? Yeah. Yes. Do you think we got good data? Because that's the key. It's all about getting good data. Do we get good data from this situation? If you looked at your neighborhood, if I took 15 blocks, just randomly 15 blocks in your town, would I get a good sampling of the entire town? There was one piece of information that I said when we were talking about the cluster sampling at the very beginning, not the very beginning, when I started talking about cluster sampling. That's a very key piece of information that this didn't do. So when we were talking about the students and we were looking at 3 groups, right? What did I say each of those clusters were done with first? Each of those clusters were randomized. Okay? So those clusters were set up of a random assortment of students. They weren't like classrooms and stuff like that. Did they do that in this situation? Are those blocks randomized? No. If you look at any block or any neighborhood, most blocks are very homogeneous. Like the actual people who live there are pretty similar. Okay? So depending on which blocks you choose, you could leave out huge demographics of the town. So if a lot of those blocks happen to be in the more affluent areas, they might like their bikes. All right? Or vice versa. If they're in the little poor areas and they don't have cars, they much rather walk or bike. So you might not get good data because the clusters weren't randomized. All right? So in all these studies, when we're looking at them, what's the keyword I keep coming back to? Random. So they have to be randomized. All right. Everything when you're looking at it, it's got to be as random as possible when you're selecting. All right. So, and actually, this was what they were looking at. So this was another study that they had done. So this one, they did the clusters, and they were looking for a pool. The town wanted to build a pool. And those were the 10 clusters that they chose. So the upper and middle class housing, most of them had pools. They don't want a city pool. The low income people didn't have a pool and they wanted a pool. So if you look at this, when they look at it, they're going to go, well, obviously they don't want a pool. So you have to look at where you're pulling that information from, because otherwise you can get stuff that doesn't necessarily represent what that town really thinks and what that town really feels. So that's where that random data really comes into play. All right. So since we've got the issue with the random sampling, let's look at another option for it. Next one's called stratified sampling. Where else have you heard the word stratified or strata? depending on what science classes you took, if you took an earth science class, strata is the different layers in rocks. Okay. So stratified sampling is often more reliable than cluster sampling because the first thing that's done is the population is divided into subpopulations. So we could do it by economic uses. So like in this example with the pool, we'd have the low, the middle, and the hot upper. We could have it split up into those. And each sample or strata is homogeneous. So whatever characteristic we're looking at, so in that situation, economics really has a play into that information. So we'd want to break it up based on economics in that situation. So we'd have our low, middle, and high income groups. Now, one of the big things in when you're looking at separating up the population is the populations do not have to be equal. The populations have to be based on the percentage in that area. So if my town has 65% low income, 25% middle income, and 10% upper income, my strata, if I'm going to break it up, I would have 65 people in the lower population, 25 people in the middle population, and I would choose 10 from that upper population. So I would randomly choose people that are in that strata based on the actual population in the town. So now I'm getting a good cross-section of the demographics. So the strata is dividing the population into subgroups. From each stratum, we're going to obtain a simple random sample proportion to that size. And you keep using the members obtained until you got the sample. So that's how we break it up. Now, is that better than clustered or worse than clustered?
You said it's usually more reliable.
More reliable. So why would we use clustered at all? It's money. All comes back to money in the end. Clusters are faster. I can hire 15 people to go ask a town for in a block in an hour. All right. If I'm going to do this, I might have to hire those 15 people. They're going to spend a day walking around all over the place to try to hit the people that we needed to hit. Okay. So this is going to cost me more money. Now, it just depends on how accurate you want your data. What's your goal? Okay. If you already have a goal in mind, you already have what you want as the outcome, you're going to hire the people who are going to get you the outcome you want. So that comes into play. All right. That's why I said you can totally lie with statistics. All right. So let's look at so we've got 2,000 members of a population have been divided into 4 strata, sizes of 400, 600, 800, and 200. We're going to use a stratified sampling and proportional analysis to obtain a sample of size of 10 from the population. So if I only want 10 people, so I've got a population, so 400, 600, 800, and 200. And I only want a total of 10 people. How many people am I taking from each one? So how many people? So remember, the people you're choosing has to be proportional to the actual strata. So out of a group of 400, how many people am I going to choose? I would choose 2. Okay, so if we look at this, if we add this up, that's 2,000, right? Okay. So if I only want 10, that means I'm picking 1 out of every 200. So I would pick 2 out of here, 3 out of here, 4 out of here, and 1 out of there. Now my groups is proportionate to my strata, and I have a good. Now, each of those people need to also be picked randomly. So they would have to do some kind of number system, or something. We go back to the computers picking out a random person. Okay? Because if you just pick the first 2 in the list, that might not be randomized. So, but this way I would get those 10 people I'd want to talk to. All right. So when we were looking at, one of the studies that we had looked at was originally was the folic acid study. Nope. We're going to go back. We'll do one other thing first. Just because I'm literally going through time too quick. Gotta love cutting and pasting. All right, so let's look at this study. Let's look at this one. We're going to go back to that pool. So a town has 250 homeowners, of which 25, 170, 50. So 25 are in the upper income, 175 are in the middle income, and 50 are in the low income. I want to obtain a sample of 20 homeowners. Okay. So we've got 25, 175, and 50, just 250. And I want 20. So how many am I going to pick from each group? So how did we figure out the 2 before? What did I do to come up with the 2 from each group? Or 2 per, what was it?
1 out of every 200.
Yeah, 1 out of every 200. So how did I figure that out? I totaled it up and I divided it, right? Okay, so in this case, I got 250 and I want 20. So if I divide those, I get what I want, right? Okay, so what's 250 divided by 20? All right. That's 12.5. All right, so I want 1 out of every 12.5 people. Okay, so out of the 25, how many people do I want? I want 2. 12.5 plus 12.5 is 25. So I want 2 out of here. How many do I want out of the 50? 4 out of there. And how many do I want out of the 175? I wanted 20 total. How many do I already have? I have 6, so I have 14 left. That's why I skipped the 175 to begin with. We could do the big number last. This way you could just subtract. So I'm 14 out of that group. Okay. So notice it's pretty straightforward and simple. And then you just got to pick those people. So, and if you're like my high school who randomly selected students that we have to go do home visits, when I had to drive around the city of Hartford, it took me 45 minutes to drive around when they could have picked 5 people that were a lot closer together instead of making me go back and forth across the city of Hartford. It's like, I live there, but I didn't feel like driving all the way around the city. So this is where time comes into play. All right. Oh, if anybody wants to take a break at any point, go get some water and stuff like that, feel free to get up and go. It's fine. You don't have to just sit here and keep listening. All right. Next up. So how do we set up a good experiment or a good, so how do we pick people well? So when we're looking at experimental design, there's a few things that we have to keep in mind. First thing is you want to control. So you want, and the two things should be comparable. So either taking it or not taking it. Those are comparable. We can compare those two. Taking Tylenol versus taking a leave. Like we can compare those two. Taking Tylenol and taking oxycodone probably wouldn't be comparable. All right. So, or if we're looking at a pregnancy study, taking a whole bunch of men, again, probably not going to be helpful for you. So when you have your control, you want to have those two groups be very similar. Okay. Second thing, randomization. That big key thing. Experimental units, which are the individuals we're looking at, should be randomly divided into groups. All right. This is where that blind or double blind studies come into play, is that the people doing the study and the people in the study should not know who they are or what group they're in. Okay? Because when you know, that starts to bring in biases. All right? So you want it completely randomized and completely as much blind as you can get it. All right? Double blind studies mean neither side knows. A blind study would mean that the doctor might know who was in the control group and who wasn't, but the patients would. Okay? So, and depending on the study, if the doctor knows who's in what, they might treat things differently, and that brings in bias. So that's where the double blind would come into play. But if it's something where what bias wouldn't really impact it, or they're not doing anything individually with the people, then it wouldn't really matter if the person doing the experiment knew what the groups were in. Okay. The last thing is replication. This is actually the key thing when you're doing a true experimental study or a true statistical study, is somebody else should be able to take your information and your procedure and replicate it precisely. Now, if they replicate it and get the same information or the same results that you do, you're golden. That you got what you got. It's a good thing. If they replicate it and get something totally different, that's when you start looking at why they do, what happened in their study or my study, what changed the results, or maybe mine was a little different, and when I set mine up, there was some bias in it that I didn't recognize, and you might have to go back and do it again. Okay, so replication is key. Right? When you're looking at, so these are two different things. So experimental units are individuals or items which the experiment's being performed on. Typically, when your units are humans, you call them subjects. So like rats would be experimental units. As horrible as this sounds, you want to dehumanize it as much as possible, because again, that brings in biases. So, but there's very specific rules on when you're doing experiments with humans, and how things have to be done, and protocols and everything else that goes into play. So that's where those come into play. All right. All right, so let's look at an example. So weight gain of cacti. Yes, we're looking at cactuses now. All right, so the golden touch cactus, a cactus native to Argentina, has an excellent landscape potential. Two researchers investigated the optimal method for producing these cacti. The research examined, among other things, the effect on hydrophilic polymer and irrigation regime on the weight gain. Lots of big words. I'm tripping over. If you're a science major, I apologize for destroying these words. Hydrophilic polymers are used in soil additives to keep moisture in the root zone. For this study, the researchers chose one specific thing, and they're abbreviated as P4, and I'm not going to try to read it because I'm going to chop it. The hydrophilic polymer was either used or not used, and 5 irrigation regimes were employed: none, light, medium, heavy, and very heavy. All right, so what were the experimental units in this study? What were the things that I was studying? The cacti. So the cacti was your experimental unit. What's the response variable? So thinking of the word, and this is one of the slides. And then probably switch up the long one. I normally switch that one up. What do you think response variable is? I didn't mention that word, but what do you think it is? In terms of the study. What's the response that I want? What's the response I'm looking for?
Says weight gain.
The weight gain. So your response variable is it's weight gain. All right. So that's the response I'm looking for. When I'm doing this, I want to see what the response is, and that's in terms of the weight gain. What are some of the factors that I'm trying to understand? There's 2 in this situation. What are the 2 factors that I'm isolating and looking at? The polymer. Yep, that's one. Nope, the hydrophilic polymer is one. That's one thing. What's the other? Yeah, the irrigation. So the 2 factors that I'm looking at is the hydrophilic polymer and the irrigation regime. So because I can change, so after I do one study with this one, I could change it to another hydrophilic polymer and do the exact same thing, and I could be able to start then comparing. What's the levels? So now we have our levels of options, right? So of the hydrophilic polymer, how many levels, what levels do I have of it? What are the different options I have for that factor? Huh? Nope, that's irrigation.
With and without.
With and without. I'm either going to give it to him or I'm not going to give it to him. Okay? So that's 2 options. Now, you actually already said it. The irrigation, I have 4, right? I have none, light, medium, heavy, and very heavy. So I have 5. So those are my factor, or the levels of the factor for that one. What are my treatments? So how many different treatments will I have? So I have 2 for the polymer, right? Giving it to him or not giving it to him. And then I have how many for the irrigation? 5, right? Okay, so how many total do I have? Oh, I have 10. Why do I have 10? Yeah. Yeah. I have to do the 5 irrigation methods with none of the polymer. And then I have to do the 5 irrigation methods with the polymer in. So I have 10 different options that I'm looking at. Remember when you looked at statistics and probability? There's your probability lesson. All right, when you're looking at it, is you have to look at both. It's like it's actually, when you probably saw it before, was a tree diagram. So you have your initial thing, you have your 2 tree lines going off of it, and then each of those have 5 going off of it. So how many is at the end? 10. Okay. So if I was going to add another polymer to it, I would then have 20, because that second polymer would have, again, it's on and off, right? And then I would have the 10. So I would have 20 different things that I'd be looking at. Okay. So
Would you be looking for us to recognize that?
we're going to look at some examples where you actually come out, like I would ask you how many different options there are at the end. And honestly, the way to do it is just multiply them. That's all you have to do. When you're looking at it, it's just multiplying the 2 factors. So honestly, most of this chapter, chapter 1, is literally just definitions and review. Once we get into chapter 2, we actually start doing a lot of the calculations and stuff. So there's not a lot of calculations in the first section. So I'm literally going through it tonight, and we're done with chapter 1. We're moving on to chapter 2. All right. There's two two ways that we're going to look at statistical design. The first one is a completely randomized design. This is where all experimental units are assigned randomly among all the treatments. So when I'm looking at this way, I take, so if I have, so the cactus example there, if I have 200 cactuses, I put 20 of them in each section. And it's just completely randomized sampling there. Now, in the cacti example, would it matter? Like, is there a whole bunch of demographics and stuff that I have to look at for cactuses? No. All right. They're very possibly all literally the exact same plant, they're just pieces cut off of one of them. So completely randomized would just totally make sense. I wouldn't have to worry necessarily about what the groups are in. The second one we look at is its randomized block design. So they're assigned randomly among all treatments separated within each block. So that goes back to that clustered and strategic one that we were looking at, where we're grouping the people the things first, and then we're assigning them, so that I get a little bit more information or more demographic breakdown. So when you're talking about people and stuff, the block design might be a better option at that situation. So suppose we want to compare the driving distances for 5 different brands of golf balls. For 40 golfers. So how would we look at it? So I've got 5 golf balls and 40 golfers. So if I'm going to do a completely randomized design, how would I split my golfers up? So groups of 8. So I'd have 5 groups of 8, right? And I'm going to give each one of them one brand of ball, right? So it would look similar to this. We've got our golfers. Split them up into groups, and each give them a brand, and compare their driving distances. I am not a golfer by any stretch of the imagination. I don't understand golf. Hit a ball as far as possible and then chase after it. Doesn't make sense to me. But lots of people like it. But what's the problem with this? Or do you think this would be a great way to determine how far the balls go? Huh? We've got skill level. What else? What else could possibly affect it? Yep. Course. Weather. How about gender? Okay, if you're looking at how far a ball is going, typically men hit the ball farther than women do, as long as they're of equal skill level, just because they're stronger. So gender might be a thing. But honestly, they do it by gender, but I'd probably do it by skill level, because I think that has a much bigger impact on the ball. So if we took it, like I said, they did it by gender. So you're going to see the group based on that, because I'm not drawing up an entire one just for this. All right. So if we took it and looked at it just by gender, so this is the difference between the completely random design and the block design. So, and the randomized and the completely random doesn't matter. All my golfers are together. I just randomly select and group them into groups, and we give them the balls. And the block design, I'm going to split it based on a demographic or some group, and then I'm going to randomize each of those groups and break down the same thing. So if I had 40 and I had 20 and 20, I'd have 20 men here, 20 women here. Each one of these 5 groups would now have 4 people in it shooting each of the balls 50 down. Okay. If I had 30 and 10, that's fine. It doesn't make a difference how the mix is. So I would still be able to look at, because now I'm going to look at comparing this group to itself and this group to itself. And then I can start looking at that information. With the cactus, I wouldn't need to really break it down like that. There's literally just the cactus. It's a plant. When we start dealing with people, we have other things to have to look at. All right. Nice. All right, let's do some problems. We're almost done, actually. We're done earlier today. Just quick before, just so I don't forget, it popped into my head. There's no class next week. It's Labor Day. So I don't see you again until the 12th. So come in, you get 1 class, and then you get a week off. How's nice is that? Oh, and I don't grade homework. If you remember the grading policy, the one big thing, because somebody always asks this question at the end when I say it, I don't grade homework. I don't want it. I don't take it. It is completely on you. I started that at the beginning. I'm like, okay, I'm going to take the homework. I'm going to grade it. I couldn't get it back to you fast enough to actually make a difference. So homework is totally on you. Go through, work on them, because like I said, all the test questions are coming from the homework assignments. All right? So it's on you to go through and practice them. If you have questions with them, you can send me an email. You can ask in class. All right? I'll take the beginning of class. Next week, I'll say, was there any questions on Chapter 1's homework? I can. Like I said, I don't know if you were here. It's like, if you want one-on-one or anything, we can do it online. I can come. I'm here Tuesdays and Thursdays for my calculus class, so I can always stay a little bit later. But yeah, so do the homework. If you have questions on it, take a picture with your phone and send me and say, hey, I don't know how to do this question. Here's the work. Here's what I tried. I didn't get it. And then I'll be able to come back and help you with that. And like I said, we can either do it on or whatever else you want. So I think, yes. Can somebody check that has the book real quick? I didn't get an actual physical copy of the book, so I don't know if the online book's the same. So yeah, it looks like the answer. Yeah. So all the odd ones are in the back of the book. But it doesn't really explain it. It just gives you the answer. So if you do it and don't get the same answer as the book and you can't figure out why, like I said, take a picture, say, hey, this is what I got. Why is it wrong? And I'll explain it to you. And we start getting into a lot of the more like the math ones where like you're going to do calculations and stuff. I have a full touchscreen computer. I can sit there and literally do out all the work and send you back and say, here's how to do it. This is all the steps and everything else. I don't have a problem doing that. And I can normally get that back pretty quickly. So like I said, it just depends on how much my students in high school are annoying me that day and if I can get a chance to sit down on my computer and do something real quick. So, but yeah, just again, take advantage of doing the problems at the end of the sections and ask questions if you have it on it. That's not a problem. So I understand math can be hard for a lot of people. I know everybody passed at least 095. And I can tell you that. Okay, so actually, this is a good question for me going forward. How many people in here is this their first math class that they've taken here? Okay. How many people passed the 095 and that was the only other class they took? Okay. How many people took like 137, like the intermediate algebra? Anybody take anything higher than that? Okay. All right. Because this section was a lot of vocabulary and a lot of definitions and stuff. When we get further on, it's going to become a lot more math, like actual calculations and formulas and stuff. So that'll give me a good idea of how I have to preface it. Like most of you didn't really take a higher level algebra class, so I'll figure out ways to simplify some of the algebra down for you or give you ways, online calculators or apps and things like that you can use to do some of that stuff. So that's fine. Because the beautiful thing is there's a calculator for just about everything online nowadays. So like I'm not going to make you sit there and do out standard deviation by hand. an upper people who took pre-calc calculus and stuff, I might, just to make sure they understood how to do it. You guys, I'll let you use a calculator or somebody to be able to do that. All right, because there's no point in me making you do 50 calculations out and hopefully you don't get any of them wrong to get the right answer. It just doesn't make sense. So I'm more concerned with you understanding what standard deviation is, how it's used, and how it can be used to predict things than being able to do 50 standard deviation or division problems. So, all right. So that's good information. All right, peanut allergies. So it says in the article, food allergies advice may be peanuts. Reports that early exposure to peanuts seems to lessen the risk of nut allergies. So over 4,000 Jewish children sampled in Britain, 1.85% had peanut allergies. And of 4,600 Jewish children sampled in Israel, where early peanut consumption, I'll tell you where it is in a second. Where early peanut consumption is more common, 0.17% had peanut allergies. The researchers chose Jewish children in both countries to limit genetic differences between groups. I believe I took all these from the chapter 1 review problems, which should be on page, it starts on page 66.
32.
Oh, this one's from 32?
32 on the book.
Okay. So it's 32 in your book. Yes. Okay. So yeah, it's the review problems at the end of the chapter. That's where I pulled all these from. So this is number 12. All right. So first question. Is this study descriptive or inferential? Okay. Why is it descriptive? Not why it was being descriptive. Okay. Oh, yeah. One thing that's going to drive you guys nuts. I don't care if you give me the right answer. I'm still going to ask the question. So never assume when I ask you why you have the answer wrong. Okay? Because I will ask you why and you'll have the answer correct and then you'll change it and you'll be right the first time. Okay? Literally because I want to know why you thought that. All right? Because a lot of this stuff is understanding. It's a 50-50 shot at this point. So it's like, why did you choose that one over the other? So remember back when the first examples, like we were looking at the baseball statistics, like the win-loss percentage and the batting averages. Those were descriptive because they were very specific situations. Inferential was where we looked at population and samples, and we looked at that data. And then we were able to infer from that because we took a sample to a greater population. So in this situation, this would be inferential. Okay, because I looked at a sample size of a population, and I can now take that data and infer something, and they're inferring something going forward. Okay. And this is actually where a lot of the research comes when they're talking about peanut allergies, saying that when you have a baby, exposing them to a lot of the different allergens and stuff helps them not get those allergies later on, where we will do the opposite. We're like, no, we're not sure if they're allergic to peanuts, don't get peanuts around them. And then when they grow up, they are actually allergic to peanuts. And like, see, I told you they were allergic to peanuts. But if you did it when they were a baby, they might not have actually gotten that. So this is actually where a study that came out and showed a lot of that stuff. Is this observational or experimental? Observational. Why?
Because it's based on the statistics that were already provided, the data that was already provided, and they didn't do anything outside of that data.
Correct. So, yep, this one was observational. All right, they didn't set up a blind study with random samples and stuff. They just looked at samples of studies that was already done. Okay. All right. Incomes of college students' parents. A researcher wants to estimate the average income of parents of college students. To accomplish that, he surveys a sample of 250 students at Yale. Is this a representative sample? Is this a good sample to determine the incomes of college students' parents across the country? And then they chose Yale. I'm like, I'm gonna go with most of those parents, probably pretty wealthy. Not all of them. There's lots of people who get scholarships in financial aid and stuff to go to Yale, but on average, they're pretty wealthy. So probably not a very good representational study. All right. If they wanted to do this, how could they have done it?
Actually ask the parents.
Well, yeah, that would have been too, but it still wouldn't have helped if they only did it at Yale. Okay. So take all the colleges in the country, randomly sample.
Or maybe just one party of it. Yeah, Southern.
All right. So the question then is so here's an interesting thing. We all live in Connecticut. So we're looking at it's like, so if we look at, say, all the colleges right around Yale. So Yale, University of New Haven, Southern, University of Bridgeport, would that demographic be the same as if I took all the colleges in Mississippi or in Alaska? Because a lot of people like to go down to the South. So maybe people like to go to University of Mississippi or Ole Miss. So, okay, we got like, as crazy as this is going to sound, Connecticut's one of the wealthiest states in the country. I know. Everybody's like, what? No, we have the only state that has more billionaires than Connecticut is California.
That's why I'm so loud.
And the only state that actually is more wealthy than Connecticut is New Jersey, not California. On per capita, like an actual median per capita basis, New Jersey is the only state that's higher than Connecticut. It's because all the people who make their money in New York live in North Jersey and Southern Connecticut. So we look at Norwich, Hartford, Waterbury, New Haven, Bridgeport. But if you look at those and you look at the money that's in Greenwich and Litchfield Hills and stuff like that, the money is insane. So Connecticut's one of the wealthiest states in the country. That's where that, like, the data and statistics that you start thinking about. It's like if you start looking at that information, that's also why you never use average and you always use median when you're starting to look at a lot of data, especially income, because when you look at average, those billionaires will pull. They'll skew that data horribly. When you start looking at median, you can get those lower income people to start pulling it down a little more because there's a lot of them. So you're looking at the middle. I think the middle in Connecticut's right around $58,000 or $60,000 right now as the median income in the state of Connecticut. All right. Couple more. Talkback Live, a production of CNN. I know we're bringing up CNN again. Conducted an online survey on various issues. One survey called a quick vote of 680 people asked, would you vote for a third-party candidate? Of the 600 people surveyed, 608 responded yes, and 72 responded no. Beneath the vote tally, the following statement regarding the sampling procedure was found. The quick vote is not scientific and reflects the opinions of only those internet users who have chosen to participate. The results cannot be assumed to represent the opinions of the internet users in general, nor the public as a whole. Quick Vote sponsor is not responsible for content functionality or the opinions expressed therein. All right. So what's wrong with this survey? Yeah. It did. Yes. It doesn't have the normal 3% on purpose because it wasn't a scientific study. Yeah.
Just because, like, people who are willing to vote third party are more likely to take the poll.
Yes. Oh God, yes. Now I will tell you, I am a third party voter. I cannot stand the Democrats. I cannot stand the Republicans. I think they're both the same people. But like, and when back in 2020 and in 2016, there's polls and stuff coming out. It's like, so Joe Jorgensen was the representative or the presidential nominee for the Libertarians, and Hallie Hawkins was the Green Party. So those are the two third-party candidates that were on all ballots across the entire country. And there was polls coming out like, look at like 60% of the people are going to vote for him. Like, no, but that's what this happens because the people who are more likely to do that are more socially active, more looking for those polls, and those polls are typically shared in groups to get people to go vote on them to get the data that they want. So it skews the data horribly. And we saw that even with polls and stuff like with masking and things like that in the state. Like they put a poll up on Channel 3's website. It's like, do you support masking? And like, and inevitably, it would be like 75% of the people would say no. And we know that if you talk to a normal person on the street, most people actually did agree with the procedures and stuff that were put in place. It's because the people who were so against it were going in droves to vote for it. And the people who were for it didn't really care. Like, okay, it's a poll. It doesn't impact me. What do I care? They weren't trying to push an agenda. So they didn't vote. And that's what happens here. So inevitably, almost everybody will go vote for either a Republican or a Democrat in pretty much every single election because they don't believe voting for a third party is going to change anything. They believe one of those two is going to win no matter what. And they believe they're throwing away their vote if they vote for a third party. So this is what you see. But yeah, so that's the one thing is like it skews. You get for a certain demographic of people voting or clicking on it. So it's like I probably can put a poll up and get any single celebrity you want to win against any politician you have. Just because you get their fan base will bomb that religiously and somebody else, the other people don't care. So that's how you get like The Rock is going to be the next president of the United States, or the worst one ever, Kim Kardashian. Oh God, Kanye, that one was hilarious. Like he literally, like people were doing polls and Kanye West was winning. I'm like, he's not even on the ballot. It's like, but people like, you know the name. When I lived in Norwich, there's and I don't know if anybody knows him. There's a lawyer called Chuck Norris. He ran in Norwich quite a bit. Like anytime I went to the thing, I'm like, I gotta vote for Chuck Norris. Chuck Norris will beat me up if I don't vote for Chuck Norris. I'm like, it was like the name. You just had to vote for him. The Kennedys had that too. Anytime people would go in to vote, if the name Kennedy was on there, they would get votes purely because people like the name Kennedy. So it's like people will vote for a variety of different reasons that have nothing to do with politics. It has a lot to do with names. And as horrible as it sounds, I think if Kanye was on the ballot, he might have actually done pretty darn well, and I would have hated to see him as president. Just because a lot of young people would have voted for him. So, all right, a couple more. 2 more, and then we're done. And then I'll let you guys out of here. An issue inside MS contained an article describing Avonex, a drug used in the treatment and relapsing of forms of multiple sclerosis. Included in the article was a report on adverse events and selected laboratory abnormalities that occur at an incidence of 2% or more among 158 multiple sclerosis patients. So think about this for a second. When they're saying adverse events and selected laboratory abnormalities, what do they think? What common term is that? Side effects. That's literally side effects. Treated with 30 milligrams once a week. In the study of 158 patients, 143 patients were given the placebo. 158 took the drug, 143 were given a placebo. Is this a study as an observational or a designed experiment? This is a designed experiment. We have a group and then we have the control group. Okay, so this is definitely a designed experiment. What's the treatment group? The ones taking the drug, right? What's the control group? The ones who are not, the ones who are taking the placebo. And what's the treatments?
Injection.
Yeah, it's the drug or not the drug, right? Those are the 2 options. So, all right. Yeah, if you see any drug and they talk about side effects, anything over 2% they have to put on them. That's why you get that massive list of side effects that might have absolutely nothing to do with the drug at all. But it happened with people in the study. That's why every single drug has a side effect of headaches. Because inevitably, 2% of the people are going to have headaches. And it's on there. So, yeah, that's why the massive list of side effects that almost nobody ever sees. But they have to list them because it could happen. All right, last one. Gas mileage. Everybody loves gas. This surprise is coming out a little bit. So they reinstitute the gas tax, which is still not on it, which is 25 cents. So at some point, gas is going to jump by 25 cents. I think it's December 1st or something like that. He's.
We have like a $2 billion surplus.
Yeah, that doesn't mean anything. Come on, we just said this. Connecticut's a tax state. It's not the Constitution. It's the tax state. And no matter who wins in November, it's still going to be the tax state. All right. Suppose that you randomly drive 24 cars, or sorry, randomly divide, not drive, 24 cars into 4 groups of 6. Each car is then randomly, or each group is then randomly assigned, and then randomly assigned 4 groups to the 4 brands of gasoline, 1 group per brand. Is this an experimental design, a completely randomized design, or a randomized block design? What's the difference between a completely randomized design and a randomized block design? There was one distinct difference. Yeah, so the block one, we have to separate it by some kind of demographic. Did we do that in this situation? Nope, we just took all the cars, right? So if we split it up into sports cars and SUVs, now we've got a block design. Suppose instead that you use 6 different model cars with whose varying characteristics, weight, horsepower, effect, gas mileage. 4 cars of each model are randomly assigned into the 4 different brands of gasoline. Is this one completely randomized or randomized block design? This is the block design because we've got to split it based on weight and horsepower, right? So we've used the demographic to split the cars. Which one's better? Which one would give you better data? The first one or the second one? The second one. Okay. Now, here's an interesting thing. So they're talking about gas mileage. So I think the EPA and the federal government upped it to 40 miles a gallon now. Don't quote me on the number. I know they just changed it, but I can't remember where it is. So a car manufacturer has to produce, their entire fleet has to produce a gas mileage that averages that number. Okay? So this is how car manufacturers can still get away with making like Corvettes and Mustangs that get horrible gas mileage because they produce enough other cars like the Priuses and stuff like that that get insanely good gas mileage to overrate those. So that's how they can still do that. And it's also why, since they're upping it, you're seeing a lot more car manufacturers start to get rid of those gasless with their cars. I think Dodge just said they're getting rid of the Challenger and the Charger. They're not going to produce those anymore because they just can't afford that low gas mileage when they have the really big ones. And the thing, because they'd much rather have the trucks that have the low gas mileage because people like the trucks more than they like the muscle cars. So it's like you can start seeing how these numbers and everything else start to affect everything in our lives. All right, so we're good tonight. And that is bad. 7:40. Yeah, it's there. We're good. We're good. You guys can go home. If you have questions, I'll stick around. You can ask them. If not, we're good. If you have questions on homework, seriously, email me. My email's on the syllabus. It's on my website too. And like I said, I get the email on my computers and phones and stuff like that. So I'll get back to you pretty quickly. If you want to meet up with me, that's fine. We can come up with a time. So I do drive from Hartford, so I'm not going to come down just for a half hour. Odds are we'll talk and see if we can do it online because that works out really, really well. So, all right. Anything else? If not, you're free to go tonight. It won't always be this early, but you too. What's up?
So I'm gonna miss one day of class because I'm going out of the country.
Which one?
It's gonna be, I leave in the 29th of October. So
You're
the 31st.
You're fine.
Fine.
So yeah, you'll miss the week. You'll miss the week of Halloween, basically.
Oh yeah.
So you're fine. Because the test is the week after. All I was looking to see is if you're going to miss a test.
Yeah.
So you're not going to miss a test.
Okay.
So
I
you're
can
fine.
always.
Yep,
leave
and
it
you can watch
today.
the video. Yep.
Perfect.
Yep. Actually, while I'm thinking about that, let me stop.
Oh,
Oh, you're fine. I can edit it later.
yeah, because I'm going to Dominican Republic. I'm gonna see my grandfather who's 90.
Oh
So-
God, that's good.
Yeah. To go see-
So I did pass the 095, but I struggled.
Gotcha.
My advisor put me in this class because I need and 2 credits for my associate.
Yeah, and you need a class.